everyone, I'm just putting together a recording so that way you can go through our entire costing model example and get a chance to see what is it like and kind of review what we would have gone over in class. Let's take a look. So I'm starting off with our cost breakdown here, and this file takes us through what is it like to calculate the materials costs, labor costs, production costs, as well as the overall total tooling costs, and to figure out what the total cost might be. Now, this methodology can be used for services, products of all different types, and because you can go in and there's always a production component, how many people are coming in or products are you making. There's always a labor component, how much time does it take and how many people are there doing this for you. And of course there's a material component of some sort, whether it's the number of desks or chairs or how much some sort of renewable resource you need to add in. You can use this type of model on any business actually. But let's go through it first and see what it all means and how you can then put it together. I like this because it starts off with an overview of the business, and then it drills down into the various aspects until you can really justify what every single cost was and then say this is how much it is. Can you use this for negotiation? Yes. It is just one of many different types of models you could use, but you can certainly use this to justify your position in a negotiation. Okay, this is where we're going to get to, which is the detail in each one of the components. But let's start off first by looking at Exhibit 5. Exhibit 5 shows us that you have several companies that are going to be providing a cost quote, and we want to understand a bit about those companies. For example, how much sales they have and how many employees they have, etc., how many shifts they work. This gives you an indication as to how much activity will be going on and how much capacity they have, and whether you're going to be the largest customer or one of the smallest. They also share, we also went through and calculated what the cost drivers were. So average hourly wage rate, the material cost, which in this case is plastic, so it's resin. Is there a relationship between indirect and direct? Which typically you'll have more indirect, for indirect versus direct labor, and see, then you get your cost center rates. So how much does it cost for a certain tonnage of press? This is how much energy is used in order for each one of the molds to be pressed down. And each time the mold gets pressed down, a certain amount of energy and tons is applied, and temperature as well, so that the plastic in the mold gets shaped into what you're expecting. And then, of course, the plastic is there as a piece, resultant piece. The cost center will tell you how much that is. Okay, Exhibit 6 goes into the various part numbers. We're going to start off by calculating and looking at just the Plinth part number. So how much is for each area, North America and Europe? What's the annual requirements? How much each part weighs in terms of ounces? What type of resin it is, the production batch size, your European supplier, the piece price for Europe, your North American supplier, and your piece price there. So we're going to use this because this is the current price per piece that you're being charged. So we want to find out if these new quotes that they've provided, and where really procurement said, hey, we want you to apply new technology, new ways to train your labor force, something needs to improve in your operation so we can get a better cost. The suppliers have all provided quotes on this plastic piece, the Plinth. Let's see what it's about. Now, Exhibit 7 goes into detail on the Plinth. So the suppliers give us 3 different cost areas: the material unit cost per unit, the labor cost per unit, and the production cost per unit. Then that gives us a total. We also get to see what type of press are they going to use. Now this tonnage is very much related to the parts per mold, how many we're going to be producing each time. And then what's the total cost of that entire tool. Okay, so they put a dollar amount here. They do have quotations from the other companies, but we're going to start with the Plinth first and see how to calculate that out. With all the reference data, now we can go and look at the actual Plinth and calculate out what's happening. Remember that this chart is showing us a comparison of material cost by each supplier: Alberto, Bergendorf, Christensen, and Del Rio. Each one has a different material cost. Each one has a different labor cost. Wow, what a nice discount from Del Rio. That's pretty good. Production cost and the total cost. Okay, so we see here that Bergendorf and Christensen are giving us some of the lower total cost per unit. But look at this, the tooling cost when we start off, $33,000. Wow. But they're giving us 8 parts per mold. Now, if a mold has 4 parts, that means every time it presses down, it's going to create 4 parts. If it has 8 parts, every time it presses down, it's going to have 8 parts created. So of course, it can run almost, it has the opportunity, if the same amount of time is used to move up and down, the one with 8 will have the opportunity to create twice as many parts, right, for each press. So you could have a reduction in time. Okay, well, chalk one up for German efficiency and methodology for them to have a higher number of parts than anyone else in their quote. Okay, let's take a look at the Plinth mold. So here we go to the Plinth mold quotation, and what we would expect to do is break down each one of these costs and really calculate out what did they actually provide us, and was there a premium to the price that they gave. You see, we had gone and done some analysis on the company. We got that initial set in Exhibit 5. We did look at the requirements of our company and did a comparison of the requirements and part weights and other specs across all the companies, as well by part number in Exhibit 6. And in Exhibit 7, we had the detailed quotes from each one of the suppliers for each part. And now we're going into the solution. So we're going to referring back to each one of those exhibits as we go through this. So look at the first one. Here we have the material cost quote. This comes exactly from Exhibit 7, and it's coming from C2. Okay, so 0.303, 0.303. Let's see what the cost drivers are. So they had given us what their resin cost was back in Exhibit 5. There it is. We might have probably gotten that from their cost of goods or some other survey with the supplier. Then how much it is per ounce, they would have part weight per ounce. So this is the Plinth. Each one is going to weigh the same. The calculated material cost. Now, how do we get that calculated material cost? Is we take the part weight per ounce, put it into, of course, their 16 ounces in a pound, what that is, and then we get a value of 0.63. Then we need to see, wait a second, they're charging us 0.3, but in fact it's 0.26 based on our calculations, so they're charging us a 15% premium right off the bat on the material cost. Something good to know. Now let's take a look at the labor cost quote. So what we see here is that there's an indirect labor. Where did we get that from? Again, Exhibit 5, we were given that. We look at the implied per part. So here we look at the labor costs quote versus the indirect and direct costs ratio. Then we look at the hourly labor rate, which again was given to us on Exhibit 5. Now, here again, it's interesting. Alberto's has a medium level rate. Look at Del Rio, 2. Wow, Germany, 15. This should really throw us some numbers here as we go through this. But in the case of Italy, 10. The implied parts. Now, for us to get this, we need to get the implied direct labor and the hourly labor rate. So the implied parts per hour is given to us here, 407. The parts per mold is 4. Now the implied cycle time is your time in seconds and hours over how many parts per mold in your overall production. And so you get 35. And now here we also see that our batch size is 5,000. And the implied hours per batch is 12.3. So how many shifts is that? Normally it would be 2 shifts. Per shift is normally 8 hours. Okay, we see here 2 shift situation. And we've broken down the 0.056 to understand that. Now this is going to come in handy for us as we go to the production quotes. The production quote shows us, and where did we get that from? This is in Exhibit 7. We see the production quote, 0.075. How does that get built up? It got built up, well, we had the machine tonnage, which was in Exhibit 7. We got the machine cost per hour, which was also given, or we can also calculate if the tonnage isn't exactly the right amount. Then here we had the implied average cycle time. So B19 was given to us before when we had calculated that from our other implied calculations. Next we go into the production cost per piece. So we take our B26, which is our machine cost per hour, divide that by the number of parts per direct labor hour, and we're getting our product cost or production cost per part. Then what's the markup or overhead? And so percent markup is here. So we take what's the difference between the cost quote versus what we had calculated through, and we see that they were taking a 0.005. And now where could this be? Well, slippage in terms of how much time it takes and what have you. And then finally, this is the overhead. So overhead is going to be what was the overhead markup versus the parts, and then we see they have a 7% overhead for us just on production. So we see a couple interesting things, an overhead or premium here, and scrap, which is on 15%. They're giving us a little bit of a markup or overhead or error conditions here in terms of production. Now let's keep going. So the piece cost subtotal, again, was given to us here, and was the sum of these 3 things here. We see the sum here is exactly that. So versus the European costing. So if we go to Exhibit 6, B13, and Exhibit 6 here, we see the European is 0.471. We take that versus 0.43, so 0.47 versus 0.43, you get 8%. What about versus North American? So that's here, what we look at is 0.468 or 0.46 about, and we're looking at the other 0.43, and we see 7%. It makes sense. Now we need to see what the tooling cost does. So we're going to take the tooling cost and spread this across the entire annual volume that we expect to purchase. And in this case, we're estimating that the tooling only has a lifetime of 1 year. So we're going to pay $13,000. They want us to pay $13,000 up front. We are not going into, for example, present cost of value, other things. We could go and do that, depreciation, etc. We'll just do straight cost here, 1 year. We have our parts per mold, which was 4, and our cost per cavity. To calculate that, we take the parts per mold divided into the total cost here, 13,000 divided by 4, and we get our 3,375. And then we get here our over the course of the year. So where did we get the year from in terms of pieces? The annual, let's take a look here. This is B6. That's the annual total volume, because what we're thinking is let's put the entire global volume through one of these suppliers. And so then this gives us our number, 0.034. We're going to add that into our piece cost subtotal. So the tooling cost spread across an entire year, adding that in, that gives us our total cost per unit. Now, what we can see here is that compared to North America, we're at the same number. But compared to the best possible is 27%. Wow, that's a big number. That's a big difference. So how did we get the 27%? Okay. In order to do all the rest of these, we would go through exactly the same flow. To get the 27%, we go to the last column. And the last column is giving us the best of everything. The best material costs, labor, production, the best speed, the best, everything that's possible is going to be the best. If we had a supplier that was able to use all of those things, then we'd be able to have the best possible costs. It gives us a bottom level in terms of using the best technology at the cheapest labor. It gives us the lowest negotiation area possible that we could bring the company to, each one of our suppliers to. Let's take a look. Best. So the first row is simple. You take the minimum of each one of the material cost quotes. Okay, that's obvious. Bergendorf at 0.269. Next one, we take the minimum of the resin costs. Well, you figure that you could ship resin anywhere and get the right price. Next, we look at what is the amount that we have for calculated material. We're going to go through and calculate out each one of these, F6 and F7, based on the cheapest resin, the lowest part rate, and that's going to give us a nice number. Divided by, again, into ounces to figure that out. So what we're looking at here is that we take the calculation of what could the best labor quote be. So now we need to look down. F15, the implied part per of direct labor per part versus the indirect to direct ratio. For labor cost quote, we need to look down. We want to calculate out using the indirect to direct ratio and the implied direct labor cost per part. Now, where did we get that from? This is a tremendous difference, 0.0027. And in fact, this labor cost quote, it almost looks like it doesn't make sense, 0.0058. It's a factor of 10 lower than the best, right? So we're looking at why. Well, the implied direct labor cost per part is calculated based on two other really improved numbers. The hourly labor rate, which is the minimum of everyone, plus the implied parts per direct labor hour, which is the best and even better than everyone. So we can see here that the hourly labor rate came from the min, and then the implied parts is calculated based on having the best parts per mole, which is 8, and the speediest cycle time, which is 28.8. So it's better than any other of the suppliers. And that's how we're really increasing and getting to what looks like a very strange number. But this is if the supplier had the best in terms of technology, they had the best in terms of lowest hourly labor rate, then we would, combining those together, have a significantly lower cost of labor costs per unit. Now we go down to our, and also of course we have the fastest batch speed as well. So that also provides us with some additional agility in the supply chain. The production cost quote, where do we get that from? We now are looking again at the average, the product cost per part, which is going to be our best, and then there's no markup. So if we look at how we got the product cost per part, we're taking the machine hour cost and calculating that against the implied parts per direct labor hour, the highest again that you could have. And so you're getting a nice number, a number better than any other for the product cost per part being calculated. Now we go down to the piece cost per subtotal. So in our theoretical case, it's really the best, 0.302. That gives us, compared to the current pricing, 36%. Let's bring in the fact that we need new molding. Now, where did we get this from? This is the lowest cost per cavity. So we take the lowest cost per cavity, 3,300, because you have to figure that it takes engineering design and other capability in order to put this together. So we use the cost per cavity and then the number of cavities. So the highest cavities we can have, which is what we had before for the fastest speed, and that gives us $27,000. We take that over the lifetime of 1 year, still the 400,000 pieces, and we get not the best, 0.068, but adding it all together, and we do still have the total best cost per unit of 0.369. That means that even the suppliers with the best pricing are not as good as our calculated case. But there's something interesting here for us to take away from the spreadsheet. Remember that Mexico, the Mexican supplier, was giving us the lowest labor cost. But if you look at what ended up happening, they had a very low labor cost, but they were giving us a 20% premium on the overall material cost. In fact, they were charging us the highest for material. And then, in terms of the implied hours per batch, they were taking the longest. Their cycle time took the longest. And they had, in tie with the other supplier, the smallest mold of 4. Although their hourly labor cost was ridiculously low, but the slow speed coupled with some other factors ended up having them have a labor cost that wasn't as low as it could have been. And so as a result, even though the Mexico labor cost was a bit less than half of the German labor cost, what we see here is that the batch speed by the Germans was more than half. And so that labor cost got offset there. Overall, that gave the performance to the German supplier and the North American supplier, which are right here in the middle, to win the bid. So now we'd have to go back and have a discussion with these two suppliers because they gave us the best quotes. And our discussion would be, what else can you do? Now here's where being a consultant comes in. Let's say that you as a consultant had gotten this spreadsheet or even had done it for the supplier. Now you can see that there's a significant difference between what they quoted with just by thinking about the technology component of the tooling versus what our theoretical calculation was. Well, what we could offer is an information systems consulting project in order to help them get to that number. So we would like to help them be able to, by using technology, have them come in and maybe get to the best labor. You have to do a step change in activity to get to this number. So it would have to be some sort of systems process. Also, the cycle time would have to improve. These are all things. You'd have to reduce your labor cost somehow. All of these imply better productivity per labor person. And as a result, an IS solution would be the best. How do we go about doing that? Well, and what would be the benefit? So back on Exhibit 7, we have here an original cost, which was just taking Alberto. So let's say we got into a consulting discussion with Alberto. The labor per piece is 0.434. The number of pieces were given for us before. And this is the original total cost that we'd expect Whirlpool to pay. However, If the best possible for labor was that, and we had a savings, and we reduced that amount from the savings amount from our labor per piece, then the total cost goes down to 153. Our total savings for our, if we tell the supplier, hey, your total savings would be $20,000, that's a 12% margin contribution. Now that supplier could consider how to bring the price a little bit further down or win the bid. Or you know what, they're tied, so they might keep it the same and keep all of this margin to themselves. But it makes for a very nice information systems project by being able to contribute this to them. And by the way, of course, this is just for one of their customers. If they have other injection molded customers, which of course they would, Alberto is making $12 million, they could see a significant improvement in their overall business. Would they be able to cast aspersions or doubts on the way you calculated it? Well, I can tell you, with the robustness of the spreadsheet that you went through, it'll be a lot harder for them to have doubts. And remember the way we went through it. We started off at Exhibit 5, an analysis of the overall company, which is what you would traditionally do. We went to Exhibit 6 and understood a bit about what's the total impact there might be, and what's the current situation, which was the European and American pricing. We went to Exhibit 7 and evaluated the quotes. Then we went to our solution around the Plinth and figured out, hey, if the supplier could make some operational improvements, then you'd actually be able to ask the supplier for even more benefits. Now this is interesting because if you can offer those operational improvements to Alberto's, let's say, and have them get improved, couldn't you also offer it to Bergendorf and others? For sure. And where would it have put Alberto's as well? Well, it certainly might have brought them into the running in terms of overall cost, because it would have reduced their cost enough so that they would have been in better competition with the other suppliers. I hope this has been helpful to you and that you'll use this in your projects ahead. Best wishes in all you do.